And like I said, Newton's third law is a tough law to take. There's some surprising features here. So what we're going to do here is that now I want to look at tougher examples. So what are tougher examples? Well, one, how about Mike Tyson versus Carlos in a boxing match? With my boxing skills, dude, you know I'm going to be going down pretty damn fast. So what actually happens with my boxing skills here? So what I'm going to do here is that I need to go in and I need to sort of like, what's going to happen? Well, I could imagine that eventually, what is Mike going to do? So if I think about me, I'm not really sure how to draw this, but I could imagine that eventually I'm going to get knocked out, right? And I might even try to block one of his shots here, but that's not likely. So then if I think about Mike, well, he sure is looking right at me here, right? He knows what to do. So you could imagine that with him, he's literally punching me there. And we could imagine the situation where, you know, I'm not sure how to draw this, but maybe it looks something like this, right? I'm definitely going to be down for the count, right? I'm going down, no doubt about it. So according to Newton's third law, what does it say? In this case, the action, you know, I'm going to run out of space, so I'm going to move this over. So in this case, here's the action. What is the action? It's Tyson's fist on Carlos's face, right? The reaction is real clear, right? By the way, in case you couldn't tell, this is Carlos and this is Tyson. And what happens? There's a reaction. God, maybe I should, right? The reaction force is going to be like this. This is going to be the reaction. And in this case, this is Carlos's face on Tyson's fist. I keep writing first for some reason. Now, you gotta ask yourself, do you believe this? Right? So according to N3L, both of these forces are equal and opposite. Right? No, equal. I don't want to say that. We already know that are equal in strength. Why does Carlos feel the punch so much more? on his face, right? Because when Mike Tyson knocks me out, isn't the right thing to say, Mike really hit Carlos's, he gave him a really good one. He really, really punched him out. But wait a minute, Newton's third law says that that's not correct, right? In your language, you're going to say that this does not seem correct, but it is. They are exactly the same. Again, there's a problem with your language of force. Now, let's maximize this contradictoriness here. Let's talk about a large truck and moth interaction. Let's talk about that. So you can imagine you're in your big truck and you're driving, let's say, on Highway 152 at night. And so when you're looking at this thing, you're seeing your truck. So when I'm thinking about this large truck, it's like really moving fast. So when I look at this guy, I'm going like, oh yeah, this truck is going real fast. All right, how fast is it going? Well, let's give it a nice good speed, 90 miles an hour, right? So you know this sucker's just like, just going really fast through there. And out in front of the windshield of the truck is the stationary moth. Who experiences the greater force? The force of the truck on the moth or the force of the moth on the truck? Well, of course, you're probably going to say, well, they have to be equal and opposite. But think about that. You can't believe that. That's not what is in everyday language. But we agree that when we look at this thing, here's what we see. We see that the force of the truck on moth, according to N3L, has to have equal and opposite forces of the moth on truck. They have to be exactly the same strength. So these two forces have the exact same strength. Unbelievable. And you got to ask the question, how can this be? How can this be true? Well, one, it is. And one more time, as I've been saying this means that the everyday term for force during interactions cannot be correct, right? They cannot be correct. So people have been misusing the word force. If you're talking about an interaction, those forces are equal and opposite. If you talk only about the moth, then the language of force is correct. But if we're talking about two interactions, that is not correct. So here is the correction. The best indicator of damage to an object is not the force, but the acceleration. And it's better not even to talk about the acceleration. We really need chapter 4 material to really explain it, and a chapter that we won't cover. The best way to explain damage is really energy and momentum. So one more time. Because I know that after you leave this class, I'll give you just a little bit more time to not think about this. And then you'll probably come back and just say, oh yeah, that truck hit the moth harder than the moth hit the truck. It's incorrect. But I'm dealing with language, and language does not change. So acceleration determines the amount of damage an object experiences. Not force. Not force. So let's go revisit the moth truck interaction. So let's go revisit the truck moth interaction. And so what we're seeing here is that I'm going to come up and grab this truck right here. So if I have this exact same situation, what's really happening here? Well, it's Newton's laws that are really telling us about this. And so what's the big deal here? The big difference between the truck and the moth, of course, is the mass. Whereas the moth has this little tiny mass, big mass for the truck, small mass for the moth. So when I look at N3L, so N3L is really clear, right? It says that the force of the moth should be equal and opposite to the force of the truck on the moth. So they're exactly the same, right? So all we know is that this guy has the same strength as this guy right there. But they have different masses. So when I look at them, we can see that the strength of these guys are exactly the same. So if I draw this guy like this is going to be the truck on moth. And then if I go and I look at the force of the moth on truck, you could see that they're exactly the same. So what's going to be the big difference? Well, the big difference here is, of course, the acceleration. So when you look at the acceleration of the truck, well, because it has such a big mass, the truck's going to have just a tiny deceleration, right? So this is so small, the truck does not feel any deceleration. On the other hand, the mass of the moth is so tiny that what you get is you feel this enormous acceleration or deceleration. So this is so large that they feel the sudden acceleration. And that's what kills the moth. So again, because this is a language issue, everyday language claims the truck hit the moth harder. Right? Then the moth hit the truck. And all I'm saying here is that this is a misconception. This is not correct. So if you were to go to tell somebody who has not had physics, you know exactly what they're going to say. They're going to say this that I just crossed out. So you got to remember that every time one uses N3L to look at similar interacting objects, you must include N2L to describe the acceleration, since that's what causes the damage at this level.